So following on from the previous video, our aim is to understand the power series. But before we try and understand this power series, let me just quickly throw you in the deep end and give you this example. And then once we've done the example, then we will go back to the original power series and try and take it step by step. So let me just throw you in the deep end. So let's say a function is defined by this, and this may seem strange, but yes, you can have a function that's defined by a series. So let's just try and this may seem strange, but let's just try and understand this for the time being. So let's just understand that. So when k equals 0, put 0 into here. 2 times 0, it would be 0. 0 factorial, that would be 1, and then put 0 into here. So that this thing here will then be 1, and then put 0 into here. This would be 0, x to the power 0, it will be 1. When k equals 0, the whole thing here will be 1. So when k equals 1, put this into here, and then put the 1 into here, and then put the 1 into here, and then the whole thing here, when k equals 1, the whole thing here will be this. Okay, and then when k equals 2, when k equals 2, put it into here, put it into here, put it into here, the whole thing here will be this. And then when k equals 3, put it into here, put it into here, put it in here, the whole thing here will equal this. So going back to here, we said let this function be this series. It's kind of strange, but you can have a function that's defined by a series. So if you look at this series is this whole thing here. But the thing is, it goes on to infinity. So you're okay if I were to give you, let's say you're okay if I were to say, oh, let a function be 1 minus x squared plus x to the power of 4 minus. You see, you're okay with this. You're okay with this. So this should be okay. So the point here is that you can define a function by this series here. So a function can be defined by this. So what we've got so far is that we've got a function here. We've got a function that's defined by a certain rule that keeps on going forever towards infinity. So this function here is defined by this whole thing here, and it goes on forever towards infinity. So now if you get a graph plotter and plot 1 take away, if you get a graph plotter and just plot the first 2 terms, that will then give you this. That will then give you an intercept of 1. So this is an intercept of 1, and then it wants to do a negative quadratic. It wants to do a negative quadratic. So now get a graph plotter and plot the first 3 terms. Then that will then give you this. That will then give you this. That will then give you the first 3 terms will then give you this thing here, the blue line, because when x is small, it wants to do a negative quadratic like this. It wants to do a negative quadratic. When x is big, it wants to do this. It wants to do the x to the power 4. So combining the 2 together, it will give you this blue line. So now get a graph plotter and plot the first 4 terms. That will then give you this. That will then give so the first 4 terms will then give you this blue line here. Will then give you this blue line here, because when x is small, it wants to do an intercept of 1 and a negative quadratic, and when it's big, so something happens in between. It actually wants to go up slightly to the power of 4. So it wants to go up slightly, and then when x is big, x to the power of 6, it wants to do x to the power of 6 when x is big. So that's down here. So combining the first 4 terms will then give you this blue line here. And then if you were to do the next term, it will then give you this. So the next term. So if you were to continue all the way to infinity, eventually it will map on top of the cosine of x graph. So this is a representation of cos of x, because if you were to continue all the way to infinity, this would just snap on top of the cos of x graph. Okay.